Hello and welcome to this lecture where I will be discussing the different storage class options that EFS provides, in addition to how you can alter and configure certain performance factors depending on your use case of EFS. Now, Amazon EFS offers two different storage classes to you, which each offer different levels of performance and costs, these being standard and infrequent access, known as IA. The standard storage class is the default storage used when using EFS. However, infrequent access is generally used if you are storing data on EFS that is rarely accessed. By selecting this class, it offers a cost reduction on your storage. The result of the cheaper storage means that there is an increased first byte latency impact when both reading and writing data in this class when compared to that of standard. The costs are also managed slightly different. When using IA, you are charged for the amount of storage space used, which is cheaper than that compared to standard. However, with IA, you are also charged for each read and write you make to the storage class. This helps to ensure that you only use the storage class for data that is not accessed very frequently, for example, data that might be required for auditing purposes or historical analysis. With the standard storage class, you are only charged on the amount of storage space used per month. Both storage classes are available in all regions where EFS is supported, and importantly, they both provide the same level of availability and durability. If you are familiar with S3, then you may also be familiar with S3 lifecycle policies for data management. Within EFS, a similar feature exists known as EFS Lifestyle Management. When enabled, EFS will automatically move data between the standard storage class and the IA storage class. This process occurs when a file has not been read or written to for a set period of days, which is configurable, and your options for this period range include 14, 30, 60 or 90 days. Depending on your selection, EFS will move the data to the IA storage class to save on cost once that period has been met. However, as soon as that same file is accessed again, the timer is reset and it is moved back to the standard storage class. Again, if it has not been accessed for a further period, it will then be moved back to IA. Every time a file is accessed, its lifecycle management timer is reset. The only exceptions to data not being moved to the IA storage class is for any files that are below 128K in size and any metadata of your files, which will all remain in the standard storage class. If your EFS file system was created after February 13th, 2019, then the lifecycle management feature can be switched on or off. Let me now take a look at the different performance modes that EFS offers. AWS are aware that EFS can be used for a number of different use cases and workloads, and as such, each use case might require a change of performance from a throughput, IOPS, and latency point of view. As a result, AWS has introduced two different performance modes that can be defined during the creation of your EFS file system, these being General Purpose and Max I/O. Now, General Purpose is a default performance mode and is typically used for most use cases, for example, home directories and general file sharing environments. It offers an all-round performance and low latency file operation, and there is a limitation of this mode allowing only up to 7,000 file system operations per second to your EFS file system. If, however, you have a huge scale architecture where your EFS file system is likely to be used by many thousands of EC2 instances concurrently and will exceed 7,000 operations per second, then you'll need to consider Max I/O. Now, this mode offers virtually unlimited amount of throughput and IOPS. The downside is, however, that your file operation latency will take a negative hit over that of general purpose. The best way to determine which performance option you need is to run tests alongside your application. If your application sits comfortably within the limit of 7,000 operations per second, then general purpose will be best suited with the added plus point of lower latency. However, if your testing confirms 7,000 operations per second may be reached or exceeded, then select Max I/O. When using the general purpose mode of operations, EFS provides a CloudWatch metric %IO limit, which will allow you to view your operations per second as a percentage of the top 7,000 limit. This allows you to make the decision to migrate and move to the Max I/O file system should your operations be reaching that limit. In addition to the two performance modes, EFS also provides two different throughput modes, and throughput is measured by the rate of megabytes. The two modes offered are bursting throughput and provision throughput. Data throughput patterns on file systems generally go through periods of relatively low activity with occasional spike in burst usage. and EFS provisions throughput capacity to help manage this random activity of high peaks. With the bursting throughput mode, which is the default mode, the amount of throughput scales as your file system grows, so the more you store, the more throughput is available to you. The default throughput available is capable of bursting to 100 megabytes per second. However, with the standard storage class, this can burst to 100 megabytes per second per terabyte of storage used within the file system. So for example, presume you have 5 terabytes of storage within your EFS file system. Your burst capacity could reach 500 megabytes per second. The duration of throughput bursting is reflected by the size of the file system itself. Through the use of credits, which are accumulated during periods of low activity operating below the baseline rate of throughput set at 50 megabytes per terabyte of storage used, which determines how long EFS can burst for. Every file system can reach its baseline throughput 100% of the time. By accumulating gain credits, your file system can then burst above your baseline limit. The number of credits will dictate how long this throughput can be maintained for. And the number of burst credits for your file system can be viewed by monitoring the CloudWatch metric of BurstCreditBalance. If you are finding that you are running out of burst credits too often, then you might need to consider using the provision throughput mode. Provision throughput allows you to burst above your allocated allowance, which is based upon your file system size. So if your file system was relatively small, but the use case for your file system required a high throughput rate, then the default bursting throughput options may not be able to process your request quick enough. In this instance, you would need to use provision throughput. However, this option does incur additional charges, and you will pay additional costs for any bursting above the default option of bursting throughput. That brings me to the end of this lecture. Now I want to shift my focus on creating and connecting to an EFS file system from a Linux-based instance.